Welcome to Astronomy. Our first unit is entitled Long Ago and Far Away, Our Place in the Cosmos. The reason I've titled this unit as such is because when we look far into space, we are actually also looking long ago into the past. The image you see here was taken by the Hubble Space Telescope in 1995. The Hubble was pointed towards an apparently empty patch of the sky, and the shutter was left open for an extended amount of time. It took 10 days to make this image. This extended amount of time allowed photons from very distant galaxies, in other words, light particles, traveling through space, to reach the detector and form the following image. In the image, you see about 3,000 different galaxies. There are some foreground stars as well. You can see those by the streaks that appear to make it look as though a plus sign is on the star. However, most of what is in the image are galaxies. Some of these galaxies are as far as 12 billion light years away. What this means is that the light from those stars that is in this image left those galaxies 12 billion years ago. In other words, this was before the solar system even formed. These are some of the first galaxies that formed in our universe. Each of the galaxies contains billions of stars, much like our Milky Way. To give you a sense of what portion of the sky this image consists of, there's an inset of the moon in the bottom left-hand side of the image, and next to that a small red box. So the amount of sky that this image comprises is about the size of that small red box, or just a tiny fraction of the size of the full moon. In that small patch of sky are these 3,000 galaxies. And you can imagine that each patch of sky, if we were able to look deep enough, would also contain thousands of galaxies. Our Milky Way is one of these galaxies. Well, not one of the galaxies in the image, of course, but one of many galaxies in the universe. And our Milky Way galaxy contains about 300 billion stars. It is 100,000 light years in diameter, and our Sun is located about 27,000 light years from the center of the Milky Way, meaning that it is more than halfway out from the center of the Milky Way. You see the Sun indicated on this cartoon with an arrow. Around that dot is a circle which shows where all the planets known to date are located. Extrasolar planets are planets which orbit stars other than our Sun. There are hundreds and hundreds of known extrasolar planets up to this point. But yet all of our discoveries, all of these planets that are known, are all contained within the small circle indicated here. You can imagine, then, that there must be billions of other worlds just in our Milky Way galaxy alone with its 300 billion stars. And yet, our Milky Way galaxy is just one of a number of galaxies in what is known as the local galactic group. Our local galactic group contains the Milky Way galaxy and some of its dwarf and satellite galaxies, such as the Large Magellanic Cloud and Small Magellanic Cloud. Each of the dwarf galaxies itself contains billions of stars. And in addition to the dwarf galaxies, there are other galaxies in our local galactic group, such as the large Andromeda galaxy. The Andromeda galaxy and the Milky Way galaxy are actually on a collision course with each other. In the future, far distant future, that is, they will collide and form into one galaxy. The Andromeda Galaxy is actually over 2 million light-years away from the Milky Way galaxy. So the space in between galaxies, known as intergalactic space, is immense. And our local group of galaxies belongs to something known as the Virgo supercluster. As you see, we are not even near the most populated region of the Virgo supercluster. The Virgo supercluster contains over 100 galaxy groups and is over 100 million light-years in diameter. And there are many superclusters just in our local region. They form filament-like structures up to 1 billion light-years in diameter. And there are large voids in between these filaments. Some of them are indicated here, such as the Capricornus void. The voids are even larger in size in some cases than the filaments or superclusters themselves. And these local superclusters still only form a few percent of the observable universe. Given how large the observable universe is, it's mind-boggling to think about the fact that more than 99.99% of the universe is actually just empty space, such as the voids between superclusters, or intergalactic space, or interstellar space, i.e. the space between stars. In fact, if by random chance you were dropped anywhere in the universe, chances are you would be dropped in complete darkness, surrounded by nothing as far as your eyes could see. But let's go back to think about the Milky Way galaxy again, our home in the cosmos. Again, the Sun is located over halfway from the most populated region of the Milky Way galaxy, the central bulge. And near the Sun are other stars in our solar neighborhood. Our closest neighbors are the Alpha Centauri system, located about 4 light-years away. But there are other stars that you may recognize here, such as Vega, Altair, or Fomalhaut. You notice that the stars appear to have different shades or colors to them. Some look reddish, or whitish, or yellowish, or possibly even orange. Later on in the term, we will learn why stars appear to have different colors. If we zoom in on our solar system itself, you see that the Sun is orbited by many objects, including planets, dwarf planets, asteroids, Kuiper Belt objects, and comets. Here is a family snapshot of the planets in our solar system and one dwarf planet, Pluto. The important thing to note about this image is that the sizes of the planets in relation to each other is to scale. However, the distance between the planets is not at all to scale. If we were to draw Jupiter as large as it appears here, and Earth as large as it appears here, and so on, the distance between the planets would not fit on your screen. Still, it is interesting to note the sizes in relation to each other. The Earth is the 3rd planet to the right from the Sun. And you see that the Sun is so large it does not even fit on the screen. We only see a tiny fraction of what would be a huge circle if we were to try and draw it. Looking more closely at the smaller planets and one dwarf planet in our solar system, we can compare the sizes of Earth to some of the other worlds. An interesting note is that Pluto is a dwarf planet, and many people have an emotional attachment to the fact that it used to be called a planet. Later on in the term, we will learn that the term dwarf planet is much more appropriate for Pluto and several other objects that orbit our solar system. So it is not a planet in the truest sense. However, we can look at the sizes of Earth and Venus and Mars and Mercury, and think about them in relation to each other. The Earth and Venus are similar in size. Meanwhile, Mars is about half the size of Earth, and Mercury is about a third of the size of Earth, or almost as small as our moon. So while we may appear to be one of the bigger terrestrial worlds, we are actually, on Earth, small by comparison to the larger worlds in our solar system. Jupiter is about 10 times the size of the Earth, and even mighty Jupiter is small in comparison to the Sun. If you were to stick Earths inside the Sun, you could fit 1 million of them inside the volume of the Sun. But if we think the Sun is large, it is not extremely large as far as stars go. There are many stars that are larger. On this scale, you see the Sun located on the left-hand side compared to Sirius, Pollux, and Arcturus. On this scale, you cannot even see the size of the Earth, and you can barely make out the size of Jupiter at 1 pixel. And there are larger stars still. For example, Rigel, Aldebaran, Betelgeuse, and Antares. Antares is over 750 times the size of our Sun, which is barely discernible on this scale. So I hope that through this lecture, I've instilled a sense of humbleness in our place in the cosmos. I hope we have given you a pause to think about the extent of our universe, its immense size, and also our tiny, tiny place within it. When the Voyager spacecraft was about 4 billion miles away from the Earth, it turned back and took a picture of the Earth. You could barely see it as a tiny speck in a sunbeam. This image was so awe-inspiring to astrophysicist Carl Sagan that he is quoted as saying, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived here, on a mote of dust suspended in a sunbeam." It was Carl Sagan's conviction that it was our duty to take care of the Earth, for it is our only place in the vastness of the cosmos.